Quantity number 20 is resistivity. Quantity number 20 is resistivity. Resistivity is basically, you can define it as resistance. It is resistance of a wire of unit length and unit area of cross section. So resistivity is actually, it is a resistance provided that the wire has a unit length and unit area of cross section. Basically, what is the difference between resistivity and resistance is that resistance depends on the factors on which resistance depends. They are length, area, temperature, and the material of which the wire is made of. These are the four factors on which the resistance depends. It depends on dimensions. Length and area are the dimensions. Then it depends on the temperature and material. Resistivity is independent of the dimensions. It only depends on the temperature and material. So resistivity only depends on the temperature and the material, nothing else. So these are the two factors on which resistivity depends. It only depends on the temperature and the material, and resistivity is independent of length and area. Now, if we write a formula for resistance and resistivity, then we should know that the resistance could be written as a formula for resistance could be written as R is equal to rho into L over A. However, in this formula, rho is the resistivity. If we make resistivity as the subject of formula from this equation, it would become rho is equal to R times A will be multiplied with R and L will be divided. So A will be multiplied with R and L will be divided. So from this formula, we can get base unit and unit of resistivity. The formula is R into A over L. First, we should get the unit of resistivity. The unit of resistivity that we can get is the unit of resistivity will become, see, resistivity is resistance into area over length. Resistance is in ohms, area is in meter square, and length is in meters. So meter and meter square will cancel out and it will be ohm meter. So we'll say that unit of resistivity is ohm meter. Now if we try to find base unit of resistivity, base unit of resistivity will be, to find the base unit we should substitute all the base units. So base unit of resistivity will be, resistivity is given as is R into A over L. R would become kilogram meter square second minus 3 ampere minus 2. This is base unit of resistance that we already found. And one method to memorize this is that resistance is power over current ka square. So if you go with power is kilogram meter square second minus 3 over current ka square will be the ampere square. So this is the base unit of resistance. Then for area it is meter square. For length it is meter. So the final form of base unit of resistivity will become kilogram meter power 2 plus 2 minus 1 second power minus 3 and ampere power minus 2. So the base unit of resistivity would be kilogram meter power 3 second power minus 3 and ampere power minus 2. So this is base unit of resistivity. This is the base unit of resistivity. So we can say that unit of resistivity is as you see it is ohm meter, and base unit of resistivity will be, and base unit of resistivity will be kilogram meter cube second minus 3 ampere minus 2. We did it right now. So this is for resistivity. Number 21 is density. Unit, base unit, and everything for density. Density and resistivity both have symbol rho. The reason for having common symbol is common behavior. Resistivity is independent of the dimensions. Density is also independent of the dimensions. Resistivity depends on temperature and material. Same is for density. Density is independent of dimensions. It only depends on the material and the temperature. Formula for density is mass over volume. So density, which is a scalar quantity, its unit is kilogram per meter cube, and its base unit is kilogram per meter cube. So the unit and base unit of density is kilogram per meter cube. This was number 21. Quantity number 22 is frequency. Frequency is actually 1 over time period. So frequency is 1 over time period. So its unit will become second inverse. So I must say that frequency, which is a scalar quantity, has a unit of hertz, and base unit of second inverse. Hertz represented by Hz is its unit, and its base unit is second inverse. So these are the units and base units of the quantity frequency. After frequency number 22 is angle. For angle, a common unit is degrees, but in SI units we do not use degrees. In SI units we use radian. Unit of angle is radian. What is a radian? A radian is an angle at the center of the sector for which the arc length, this arc length will be equal to the radius. So if arc length becomes equal to the radius, then angle at the center would be 1 radian. So this is the definition of radian. Now what would be the base unit for angle? Base unit for angle. Base unit for angle would be, we need some formula for angle in this regard. So there are two formulae for angle that you can use. You can find its base unit using formula for arc length, or the other option is using formula for area of sector. Any formula that is suitable for you or easy to memorize for you, you can use them. Formula for arc length is given as radius times angle in radian. Arc length is given as radius times angle in radians. Using formula for area of sector is given as 1 over 2 r square theta. Arc length S will be equal to r theta. Now, if we look at this situation, then we can get a base unit for angle. However, before that, from where we get this formula for area of sector? In your O level, you studied area of sector is theta over 360 into pi r square. Now 360 degrees that you studied in your O level, in radians it is 2 pi radians. So in a complete circle, the angle can be given as 360 degrees, or you can give it as 2 pi radians. Now if you convert the unit of angle from degree to radians, then the same formula could be written as theta in radians divided by 2 pi divided by 2 pi into pi r square. So pi will be cancelled out with pi, and remaining thing will be area is equal to theta over 2 into r square. So area would become 1 over 2 r square theta. This is formula for area of sector. So arc length is r theta and area of sector is 1 over 2 r square theta. These are the formulae. Using these formulae, we can find the units and base units. So base unit for angle. Base unit for angle would be, as you see, area is equal to 1 over 2 r square theta. Now, if we make theta as a subject of formula, it would become theta is equal to 2 times area. Theta is equal to 2 times area over r square. 2 has no unit, area has unit of meter square, and r has a unit of meter. This gives that angle has no base unit. And if something has no base unit, it is called dimensionless. So angle is a dimensionless. Angle is a dimensionless quantity. We must say that the angle and must say that the angle and strain both are dimensionless. So if a quantity has no base units, it is called dimensionless. Now unit for angle is radian. Unit of angle is radian and its base unit is base unit of angle is no base unit, it is dimensionless. Angle has no base unit, that's why it is called dimensionless. The last quantity that we have to cover is number 24 is specific heat capacity. Number 24 is specific heat capacity. In your O level, you are familiar with this and you to represent this with smaller c. It was basically heat needed to raise the temperature of a unit mass by 1 unit. And you also know that from your O level that temperature in Kelvin is equal to temperature in degrees Celsius plus 273.15. However, you can also write change of temperature in Kelvin will be the change of temperature in degree Celsius. So for change of temperature, we have same units. For temperature, we have different formula, and for change of temperature, the formula is same. And a very famous formula for you in your O level was Q is equal to mc delta theta. In this formula, different variables are Q here is, as you know, it is heat. M in this formula is mass. C in this formula is specific heat capacity. And delta theta is change in temperature. And change in temperature, if you give it in degrees Celsius or you give it in Kelvin, it has same value. Because change is same, the values are different. Now let's suppose we write unit of specific heat capacity. Unit of specific heat capacity. So according to the given formula, we can write its unit. The given formula is heat is equal to mass into specific heat capacity into change of temperature. This formula will return the units. Heat is in joules, mass is in kilogram, smaller c is the one whose unit is to be found, and delta theta could be in Kelvin or it could be in degrees Celsius. So base unit for smaller c will become joule per kilogram per Kelvin, or the other form could be joules needed for 1 kg for 1 degree Celsius. Now let's write base unit of specific heat capacity. Base units of specific heat capacity smaller c. So base unit of specific heat capacity or smaller c, it would become Q is equal to mc delta theta. And if we write base units, then unit of heat or energy. So first of all, you should know that base unit for work, heat, energy, and all other quantities which are in joules, their base unit will be kilogram meter square second minus 2. So this is base unit for heat. I will substitute all the units. Q is equal to m into c into delta theta. So unit for Q is kilogram meter square second minus 2. On the right hand side, it is meter, C, and it is Kelvin. So it would become kilogram meter square second minus 2 divided by meter and Kelvin. Smaller c. So base unit of smaller c will become 1 second. For m, it should have been kilogram. Kilogram meter square second minus 2. Here the m is quantity, not the unit. So it would become kilogram, smaller c, and then it is Kelvin, because we have used SI units and base units. So kilogram is cancelled out with kilogram, and the final unit for specific heat capacity will become meter square second minus 2, and Kelvin will be divided. So base unit for specific heat capacity would be meter square second minus 2 and Kelvin inverse. So we are done with all the base units. In the next class we'll cover the homogeneity and its applications. In next class, homogeneity and its applications.